Hello everybody. Let's learn OSI model. Imagine you want to send a simple text message to your friend across the world. It feels instant, but behind the scene, your message travels through a massive invisible digital assembly line. To keep this assembly line running smoothly, engineers created the OSI model. Open Systems Interdisciplinary Reference Model. Think of it as a 7-story office building. Your message starts at the top floor, gets wrapped in envelopes, and stamped at each floor as it goes down, travels across the street, and then climbs up the floors of your friend's building. Let's take the elevator to the top floor and watch a message travel down. Floor 1, the application layer, the window. This is the only floor you are actually see. It's the user interface, your web browser, either Chrome, Edge, or your messaging app. The job is it catches your input when you type hey and hit send. Floor 7 grabs the data and hands it to the workers below. Floor 6, the presentation layer, the translator. Computers speaks different languages and security matters. Floor 6 ensures your data is in a format everyone can understand. The job is it handles encryption and compression. It turns your typed text into a clean, standardized stream of data. Floor 5, the session layer, the manager. Before any data moves, a connection needs to be built. Floor 5 is like your switchboard operator setting up a phone call. The job is it opens, manages, and closes the session between your device and your friend's device. If you are downloading a massive file and your Wi-Fi blinks, that session layer makes sure it resumes where it left off instead of starting over. Floor 4, the transport layer, the delivery coordinator. Things are getting physical now. Your message might be too big to send in one massive chunk. So floor 4 breaks it down. The job is it chops your data into smaller pieces called segments. It also decides how to send them. Should it use TCP or UDP protocol? Floor 3, the network layer, the GPS. Now that we have small segments, we need to know how to route and across the global internet. The job is this floor takes those segments and places them into envelopes called packets. Crucially, it stamps the IP addresses of both you and your friend onto the envelope. Routers live in a floor, acting like postal workers directing traffic to the fastest path. Floor 2, the data link layer, the local courier. The network layer handles a grand global map, but floor 2 handles the literal next step in the physical world. It connects your device to your immediate router or switch. The job is it takes the packets and put them into the final container called frame. Instead of IP addresses, it uses MAC addresses, a permanent physical serial number burned into your device's network card. Floor 1, the physical layer, the cables and waves. We have reached the ground floor. The data is entirely out of the software now. The job is this floor turns these digital frames into a raw physical signal, ones and zeros. It translates data into electrical pulses in a copper wire, flashes of lights in the fiber optical cable, or radio waves traveling through the air via Wi-Fi. So now, once those ones and zeros fly across the world and hits your friend's device, the exact opposite happens. Their device catches the physical signals in floor 1, opens the frame in floor 2, checks the IP addresses in floor 3, pieces the segments back together on floor 4, maintains the connection on floor 5, decrypts and text on floor 6, and pops the message up onto their screen on floor 7. Within the fraction of a second, your message has traveled down one 7-story building and raised up another.